Hello friends, welcome to BISP Solutions. Myself Ashwin and I work as a technical consultant at BISP Solutions. BISP Solutions is a tech company and provide technological solutions across the world. Now, this is our series on linear regression. In this video, I am going to show you how to apply linear regression on sales order data, which is extracted from NetSuite, right? So our agenda is to apply linear regression on sales order data. Now, see here, linear regression is used for predictive analysis. Now, you can see here, linear regression is an algorithm that provides a linear relationship between an independent variable and dependent variable. See, for example, we are having a bulk amount of sales order data for the last few years, right? And we want to predict how much sales or profit will be there in upcoming years. So this is called prediction. And for prediction purpose, the algorithm linear regression is used, right? So if you see here, there is a dependent variable, independent variable, right? So now let's do some practical work. See here, I have one saved search and that saved search name is SO search ML, and this saved search is created only for sales order. I have extracted the sales orders from NetSuite, and you can see here, type is sales order, right? So I have extracted the sales order, all information of sales order from NetSuite, right? Actually, it's a for the last few months, it's a sales order data. Okay, now what I have done here, let's come here. This is linear regression. Now I have extracted that sales order data into here. You can see I have named that CSV file as financials, right? Financials data. Okay. Now see here what I have done first. This is a Jupyter notebook. I have already created few videos on data science. So I recommend you to watch those videos if you are new to Jupyter and Anaconda application, right? Okay, now what we have done here, I have imported pandas library, numpy library, import math.library for calculation and matplotlib for plotting the diagram. Okay, now see here, financial data, pd.read CSV. Now the same CSV file I have extracted, I have removed some unnecessary columns. I have taken only these segment, government segment, country, item name, item price, total revenue, profit, month and year. Now, these are the data that we have. Now, if you see here, there is a text data. Now, since when we apply linear regression, so linear regression can't be applied on text data. It can be applied on numeric data only. So what we have to do first, we have converted this text into numeric. For example, wherever Canada is written, we have to create one more row, and wherever Canada is written, we have written 1 and otherwise 0. So this is how we have converted the text data into numerical data. Now fin data, financial data, pd.get dummies. Now see here, we have taken get dummies. So what it has done, it has suppose country France, Germany. So it has taken these countries and converted into 0 and 1, right? So definitely few columns will be increased. So in this way, all the information is converted into numeric. You can see here fin data, all this, right? For example, wherever country Canada is there, you will see there is a 0 and 1, right? So in this way, we have converted this. Then we have taken this data into X variable, and we have taken the remaining profit variable into Y variable. Why this we have done? Because there is we have to plot a diagram into X and Y axis. Look at this. So what we have to do? we have to first keep one data in y-axis, that is the profit. So profit column we have taken in y variable, and financial remaining every data in x variable, right? So this is how we have done. So this is x data and this is y data, right? This is the profit. Now what we have done here, sklearn model selection trans test split. So in linear regression, we have to split the data into trainable data and testable data. Now see here, trainable data means we have to train the data, and 20% data we use for testing. So you see here, test size equal to 0.02. 0.02 means, sorry, 0.2. 0.2 means 20% data we have taken for testing purpose, and 80% data we have taken for training purpose. So that is why we have written xtrain dot shape. We have see here xtrain dot shape. What is the xtrain dot shape? So training data, this is training data, this is testing data. Again, xtest dot shape, 88% for training, 20% for testing, right? So similarly, y train, y shape, right? So what we have done now, from sklearn linear model, import linear regression. Now this library we have invoked, right? LR equal to linear regression, LR equal to fit. Now what is this fit? LR fit. LR dot fit means it fits your trainable data, X train and Y train into linear regression, right? And then LR dot score. What is the LR dot score, right? So here you see y underscore prediction. Now it's the time to predict the data. So LR dot predict X test. So whatever the testing data that we have taken, X test, here somewhere X test is there. X test. Where is the X test? Here is X test, right? Here, X test. That is 20% of data. Then we have taken under consideration for prediction, and prediction underscore DF, we have created one data frame where actual value equal to Y test, testing data. Predicted value equal to Y predict, whatever the predicted value is. And difference equal to Y test minus Y predicted. So this is our data that we receive from linear prediction. What is the actual data? This is the actual data. What is predicted data? This is predicted data. And this is the difference. Now you can see lots and lots of difference. For example, here 3744 and 5324. There is too much difference here, right? So linear prediction shows the variance also. Now see here. Now we have done, now we received this data. But how to plot this data? So import seaborn dot as SNS. So SNS dot reg plot, regression plot, x equal to y underscore test, y equal to y underscore predict. You can see here test and predict, and CI none, and scatter value, that is blue, and color line is red. So red color is our prediction, blue color is our original data. So you can see the prediction. So this is how we make our predictions, that these are the benefits and profits that we receive within the last few years, and what would be our future prediction. So let's have a quick recap here again. You can see here, these are the libraries. First of all, what we have done, we have extracted the CSV file, then we have converted text data into the numerical data, because text data, you can't apply linear regression. After that, what we have done, we have splitted the data into trainable data and testable data, test and train. And then what we have done here, we have fit the data into linear regression and extracted predicted data. This is the predicted data, and since this is not a meaningful data, nobody can understand like this. So we have plot that data into the chart format. So this is how we have applied linear regression on sales order data. Whatever we receive sales order in the form of CSV, that CSV format, it is better to provide such type of diagram to higher authorities so that they can easily understand right? So guys, I recommend you to practice this with your test data, and if you face any difficulty, then you can write down in the comment box. I will definitely solve them. So guys, this is all about linear regression, right? So in our next video, we will see what is polynomial regression. Till then, you practice, guys, and those who are new to this channel, please subscribe my channel, right? So guys, thank you, and thank you for watching the video. Thank you.